This is another day in section 5.5 using now each section is going to have a formula set, and then we're going to use those formulas. So these first set of formulas that would probably be on your pink sheet, I think it was, that I gave you, are the ones we're going to be talking about in the first couple of examples. They talk about developing these formulas. That's more for advanced math school or something in college. We're not going to do that. Move on. Let's try some examples. See how fast that was? We're already on page 2. Yes. What we're going to do is we're going to change some of these equations so that we can solve them. So in the first part here, bless you, I see that I have this thing that says sine of 2x. And on the previous page, if I change that, based on the formula, I see that I have 2 sine x. That's the same as the red stuff. And then I have the rest of my formula, which says minus cosine x equals 0. So the big idea today is we're still solving equations, but what we're going to do is we're going to convert some things so that it makes our life a little bit. Solve these things. Oh, look, I noticed that there's a cosine in both the first term and the second term, red and black. So I'm going to factor out a cosine. So I have cosine of x, parentheses, 2 sine x minus 1 equals 0. In case you don't remember, this has to do with the zero product property, meaning if there's two things being multiplied and you get a 0, 0. So you write down either the cosine of x, really, equals 0, or sine of 2 times the sine of x, sine of x minus 1 equals 0. So we have two separate equations here that we're going to be solving. Let's say we look at the left-hand side. And you ask yourself, where is the cosine 0? No, 1 is not on the unit circle.
It's not. No, the 90.
Let's try at
80 degrees.
pi over 2.
Oh, no. Yeah, 90 degrees.
Or 3 pi over 2.
And 3 pi over 2. That's a little scary. Move the 1. In the second one, if I move the 1 over and divide by 2, I get the sine of x equal to 1/2 when I solve that equation for the sine. And then the question becomes, where is my sine equal to 1/2? You should know that those are the pi over 6 things on your unit circle. And you're looking for the ones that are positive, which occur in the first and the second quadrant. Answers would be pi over 6 and 5 pi over 6.
Wow.
And those are your x values. And so notice how there are 4 answers. In number 2, we see that sine of 2x again. So I'm going to change the sine of 2x into 2, which is 2 sine x cosine x, 2 and the stuff which was 2 cosine x and equal 0. From there, I notice that there's a 2 cosine 2 and a cosine of x in each situation. So I'm going to factor out a 2 cosine x. Now you could factor out just cosine x, but it makes it simpler in the long run if you factor out everything you can factor out. Left over, I will have a 1 plus the sine of x and equal 0. Notice how in each of these cases we're setting things equal to 0 and trying to solve 0. Us in the long run, get it equal to 0. Zero product property applies again, meaning that either 2 times the cosine of x is equal to 0, or 1 plus the sine of x. One of those two scenarios. In the left side of this situation, if I divide both sides by 2, I get the cosine of x is equal to 0, which then I ask myself, hey, where's the cosine 0?
Pi over 2, 3
Oh, that's right, we just did that one. Pi over 2 and 3 pi over 2. Notice how I'm answering in radians. Why am I answering in radians?
And an interval of 0 to 2 pi.
Because it says it's an integral of 0 to 2 pi, which means they want your answer in radians. Be careful. On the test, if it asks for that, you have to give it in radians. Second set. If I move the 1 to the other side, this is asking me, where is the sign -1? And you say
3 pi over
3 pi over 2. Notice how you wrote it down twice. You don't have to write it down twice. The solution set on the left-hand side, or it doesn't. You don't get any points off if you write it down again. No big deal. The two answers are pi over 2 and 3 pi over 2. Just so happens that the other set are contained within the first. In number 3, I see a clue. I see this clue. What do you think that highlighted green clue tells me to do?
second.
Joe?
Second column.
So that highlighted clue is telling us draw a triangle. So I draw a triangle. The highlighted part is also telling us that that triangle that I'm going to draw is in the second quadrant based on the restrictions. So I draw that triangle in the second quadrant based on my restrictions. They name the angle x. So I put an x next to the origin. And they tell me that the sine, which is the opposite over the hypotenuse, is 12/13. That does mean, of course, that I can find out that the other leg is going to be -5. Now, after they've done that, they say to find 3 different things. The first thing that they tell me to find is this sine of 2x. So let's do that first. The sine of 2x from our formulas on the front part of this section 5 said that we have 2 times the sine of x, sine of x, which means that I have 2 times, looking at sine of x. Oh wait, they even told me, right? 12/13. Was negative, and then the cosine was -5/13. My light blue triangle. If I multiply this all together, 169. Because remember, the 2 in front is really like 2 over. You'll notice that in the 3 formulas, I only memorize 1. So the one I know is x minus the sine squared of x. They will all produce the same number. Pick one, memorize it. Doesn't matter which one, I don't care. What does this mean? This means that I have something squared minus something squared. The cosine we know is -5/13, and the sine was 12/13. If I simplify that, I get 25 over 169 minus 144 over 169 for a grand total of negative 119 over 169. That's our cosine of 2x. These are our super sneaky notes. What I want to show you is, instead of doing what they have for formulas for the tangent of 2x, what I would do, because I've already done a lot of work, is I would realize that the tangent of 2x is really the sine of 2x divided by the cosine of 2x. Oh, and hey, I've already found those answers.
Ooh, yeah.
So why bother using the formula when I already have the answers for these two things? So this is really like saying negative 120 over 169 divided by negative 119 over 169. And when I simplify that, I end up with 120 1/19ths, if you remember anything about simplifying fractions. Invert and multiply the bottom. You can do that on your own, or feel free to use your calculator. This next slide involves different formulas. They're called the half angle formulas. And basically what's happening is as you look at a problem, you notice that the angle that you talk about is not on the unit circle. So you find an angle that is on the unit circle that's twice as big because the angle that you see is half of what's going on. So I'm going to rewrite this as the cosine of 330 all over 2, because 330 is double the 165, or in other words, 165 is half of the 330. Looking up above, I see that when I look at my half angle formulas, the cosine says to do the following: plus or minus the square root of 1 plus the cosine of whatever that new angle was on top, 330 that is, all over 2.
Wouldn't that be minus though, because it's like 5 and 2?
No, because it's always whatever the angle is, and you just go from there.
Then why did we double 165?
I'm going to get there. Hang on. You're a little bit ahead of me. Next, I look at my unit circle. I look for the cosine of 330. And this is what takes care of your question, Gannon. When you look at the cosine of 330, it automatically takes into consideration the sine of that angle, because it'll be positive or negative. And then that fixes it for us. So now, I know that I have plus or minus the square root of 1. And what is the cosine of 330? Unit circle. Thank you. Root 3 over 2. And that's all over 2. Now on your test, if you get this far, you'll get all the points but 1. Guess what the last point's for? Simplifying. So here we go. Here comes the fun part. In order to simplify, on the top, I need a common denominator. So this will now be plus or minus the square root of 2 over 2 plus root 3 over 2 all over 2. And then if I simplify that, I get plus or minus, and again all I'm doing now is spending time simplifying, 2 plus root 3 on the top all over 2, and all of that is over 2, which we know is really the same as 2 over 1. So that when I invert and multiply, my final answer will be plus or minus the square root of 2 plus radical 3 all over 4. Now, most people would stop there, and that's why I said final answer, but the truth is you can square root the top and square root the bottom, so really your final answer should be plus or minus radical 2 plus root 3. And what's the square root of 4? 2. So in the purple is really my final answer. The next one. I see the sine of 105. So instead of writing it that way, I'm going to write it as the sine of 210 over 2. So 105 times 2 is the 210 on the top. Then I just go up and I look at my formula stuff. My formula stuff says that I'm going to have plus or minus the square root of 1 minus the cosine of 210 all over 2.
What did he sign?
What does the formula say?